Hello everyone. Um, my talk is performance of mostly known information criteria for different types of econometric time series models. Um, I'm so sorry for not being able to participate in the at the time on the 28th of October. So I'm preparing this video for the missing place of for my talk. Um, okay. Um, Before I start to tell about the performance, talk about the mostly known information criteria, I'd like to just mention about the time series we use mostly for econometric time series. So any series of observations ordered along a single dimension such as time may be thought of as a time series. So the emphasis in time series analysis is the study of dependence among the observations at different points in time. So many economic and financial variables such as prices, sales, stocks, and GDP and its components, stock returns, interest rates, and foreign exchange rates are observed over time naturally, so seasonal. So most econometric time series are observed to be seasonal. So this is why the time series we consider in this study are mostly seasonal. So this is why we consider 17 different models in these studies, and we try to use the information criteria to make comparison within using those 17 different models. So let me give you, just introduce you the models we consider for the data generation. So those are the models. The first one is say that the very simple model having only a constant term is with white noise. This is the simplest model you can ever fit. And this is the first type model we generate 10,000 replication. And the main idea in our study is we generated data from one of these models, and we try to fit the generated model. We fit the model into 17 different models and try to use the information criteria to check on which model fit best out of 17 different models. For instance, so you generate the data from the first model and try to fit the model to the first and the second and third, fourth and fifth and 17 until 17, and check that which information criteria present you which model is going to be selected in out of five different information criteria. So this is the main idea of the study. Um, so the second model, the first model is very simple one, very basic model, and the second one is having a time trend with the white noise. This is another. So this type of model we come across a lot in daily life. And the third one, the third model we considered is another type of model we come across a lot in practice, having a stochastic trend. Y3 t minus 1 is a stochastic trend and having no constant. And the fourth model is the combination of the first and the second model you might consider is a combination of the first and the second, including a constant term for the second model. And the fifth model is um, a combination of the first and the third model, having including a constant term. And the sixth model is having a deterministic seasonality, only a deterministic seasonality with white noise, error term, And the next one is including the first model into the sixth and the eighth model having a stochastic seasonal term. So since the data we mostly observe in time series analysis, we mostly work with monthly data. So I decided to include monthly, seasonal, monthly the stochastic term. So the ninth model, the next model is also including the constant term. And this in the next slide, I have the model 10 having both the time trend and seasonal um, deterministic seasonal term, deterministic trend, both. And the 11th model, you also added a constant, extending the model in given in 10 and the 12, having a deterministic trend, and in place of seasonal terms, we include stochastic seasonal term, and in the 13th one, and you also include a constant, and the next one in 14, we have both stochastic trend and deterministic seasonal terms. And the next one we generalize, we have a constant included constant term on the one in 14, and the next one is we remove the seasonality, the deterministic seasonal terms, and including stochastic seasonality terms and stochastic trend. And in the final one, um, we include also a constant for the model 16. So all those models are generated, and the generation process is performed using EV's program. I developed a code to generate all this model and fit all this model and check that which model, whether the generated model fit best in terms of information criteria. We check that. Okay, after we do perform the generation, we perform the fitting process, and we decided to study the generation for 9 different sample sizes starting from 60. So 60 is a small sample size for time series analysis. We consider the smallest to be 60, and at 500 is the largest sample size we consider. We could consider maybe 1000, or it won't make any difference, and we start with 500. The first table is using the Akaiki information criterion to fit the generated time series into 17 different model. So let me show you the first. Um, so look at the first row is telling you 41.69, 41.636, and it keeps going to, in average, 40.99 is telling you that if you have a time series data generated from just a constant term, so it is a constant yt equals c, and this is the model we considered, and you try to fit this time series data into different models. You fit different 17 different models. This model, 17 of them, you consider them for the generated data, and you see that 14.99% of the time series are correctly classified for the first model using the Akaiki information criterion. So if you keep going to see the red color, those are very successful, means in average. So let's see why 90 for using the Akaiki information criterion. If you have a model, a data set, a time series data having in reality a constant term, a stochastic seasonal term, and it is very likely using the Akaike information criterion, you're very likely to fit the actual model to catch the actual model. So 71% you will have a chance to fit the actual model by 71%. Um, and even this is going to be more than 99.9 for not for a series number 13, having if the time series has a deterministic trend and a stochastic seasonal term in general, and a Akaike information criterion will definitely catch the actual model, fit the right model, and it won't fit the other models. Even if you fit in place of 13, you try to fit 12, it will tell you that the Akaike will tell you that this model is coming, this time series is coming from the model number 13. And 17 is also very successful using the Akaike information criterion. And the others are the least successful, maybe 37.20. So this is the model number 6. If you have a model with deterministic seasonal term, the deterministic seasonality, so Akaike is unlikely to catch the actual model. But this is increasing when the sample size is increasing, the success is very high using a Kaiki information criterion. Let's see what about the other information criterion. The next one, the Hanan Queen. This is another popular information criterion. So we also apply the same generated data set, 10,000 with 10,000 replications, and we see that the Hanan Queen is very successful for models having less terms, because the Hanan Queen is likely to um, penaltize, give penalty to the model if you have many terms. It doesn't like many terms. So look at the number 99 20 19%, 19.99 and 20. So those two, see that you see that those two models have many terms. So Hanan Queen is a criterion that catch the models having less terms. But even for these two models, when the sample size is very high and the classification rate, the catching rate is very high, the Hanen is very successful for the large sample sizes. Okay, and you see that all the small classification rate of coming from the models having very many terms in the model. So if you look at that, if you have a deterministic trend and deterministic seasonal term, so it means the model contains more than 12 13 terms in the model. So the Hanan Queen doesn't like many terms in the model, so it's not very likely to catch the actual model. Okay, and the next one is using the mean square error. The mean square error is somehow is surprisingly successful for number 10, 11, and you go down and the other starting from 1 to 9, the model from 1 to 9 is not really successful even in every sample sizes. So mean square error is not a popular information criterion, but it can sometimes be used. And the Schwarz information criterion is very uh, it is also like the Hanan Queen. When you have many terms, it's not very likely to catch the actual model. See that this is 5%. It misclassify the actual model, the time series you generate, it doesn't fit from the generated process. But it is also successful. The Schwarz information criterion is also successful, especially for large sample size from 200. It's very successful, except for some of the models. And the log likelihood is also used as information criterion. It is very surprising because it is most scientists use, most researchers in time series analysis, in econometric time series analysis, use the log likelihood as an information criterion, and see that most of the time series are not correctly classified using the log likelihood. So I wouldn't really recommend the log likelihood to use an information criterion to pick up the right model that you fit. Okay, the next one is the adjusted R square. The adjusted R square maybe is used in regression analysis. Linear system regression analysis is a good information criterion. In time series analysis is also not very much, it's not bad, especially when you have many terms in the model. It's a good one. um, but if you have very few terms, the adjusted R square is also not really that successful. But if you intend to include, and if you know that somehow your time series should have many terms, so you can use the adjusted R square as well. Okay, this time what I did is mm, I bring up all the information criterion at this in the same table, six of them in the same table, avoiding the sample size, just comparing in general, just to let you see how uh, they classify the correct classification rate. For the first model, Schwarz information criterion is the best, and the second, Han and Queen both compete. They have the competence. And if you go down the last model, in general, um, they are mostly successful, in average, of course. And I also have another table. This time what I do is the difference between this one and this one. So now I'm avoiding the model. I consider 17 different model, ignoring the 17 different model this time. In average, taking the sample size into consideration this time, and I can say that in average, Akaiki information criterion is very good in classification from for sample sizes over 150, between 150 and 250. They're best. For Akaiki is best for this type of sample sizes, and the Han and Queen is for the 500. The sample size, when the sample size is very large, Han and Queen is much better than the other information criterion, and the mean square error is not really successful in any case, in any sample size, so you can avoid the mean square error. And the Schwarz information criterion um, is in average, the correct, I made a mistake here, 53.99 is not very much. Yeah, for small sample size, the Schwarz information criterion is also nice, and the log likelihood, we can avoid the log likelihood, and the adjusted R square is very surprising, especially when you have the sample size to be 60, from 60 to 120. So I would recommend you to use the adjusted R square. And if the sample size is a bit more than greater than 150, between 150 and 250 in general, you can use the Akaike information criterion. And then for 500 large sample sizes, just use the Han and Queen. Okay, so to conclude my result, I have some itemized the important result. As the number of sample sizes decreases, the correct classification rate has been dramatically fallen no matter what type of seasonal time series for any information criteria. If the time series is to contain a stochastic seasonal component, then the fitted model is at least 70% likely to be correctly classified by archaic information criteria. For any other type of time series, the classification rate is failure for Y archaic information criteria. And in general, archaic information criteria and surprisingly adjusted R square are the best in selecting the appropriate model. Yet the average misclassification rate is still about 40% in general. If the time series has a deterministic seasonal component, the Schwarz information criterion seems to be out of use. Unlike the literature interpretation, we suggest not using the log likelihood as an information criterion, and in conclusion, the result obtained from the simulation study may be used as a guide for using the appropriate information criterion for selecting the best fitted model. In the end, we still think that an information criterion that's free of both sample size and time series type may be developed to overcome the misclassification rate, and this is definitely there is a lack of research on information criterion, and it's still an urgent. We should develop a new one that will be robust and that will catch the right model, and without considering the sample size, the type of series, the number of terms in the model, it should pick up the correct model. So this is the end of my talk. I hope you enjoyed my talk. If you have any question, I haven't typed my email, so I'm going to type it by hand now. This is my email address: GATILLA at mu dot edu for education.tr. So you can write me on my email address asking your question. I will be happy to answer. So this is my talk. Thanks a lot.